So hello everyone, and we are group 6, and our topic is indoor air quality monitoring system, and I'm Liu Hong Irvin. And let me briefly introduce our topic and the reason why we choose this topic. Recently, the air pollution problem is quite severe in Hong Kong, and also because of the emission of the tear gases, it may seriously affect the health of the Hong Kong people. And allergy is one of the most common disease for Hong Kong people, and in some extreme cases, it may even kill them as well. Yes. Besides, the public awareness of the air quality problem is not enough of the Hong Kong people, especially in the indoor environment. And for example, a woman may stay in a shop for a long time for choosing and purchasing their outfits. And if the indoor air quality is poor in the shop, and it may seriously affect their health. And so we would like to design an indoor air quality monitoring system for tracking the indoor air quality data, and we would like to improve the working environment for the employees, which they may stay in the company to work for a long time. And also we want to provide a safer place for customers to consume without worries. And the hardware design of the project is responsible for me, and I would like to talk about the hardware components that are in our design just temporarily. And they are the Arduino board, an LCD display panel, the gas sensor, the variable resistor, and the resistors, buzzer, and the LEDs. And in the simulation, the above image shows the circuit wheels of our design. So after we start the simulation, the message "Welcome to Indoor Air Quality Monitoring System" will be displayed in the LCD display panel. And after collecting the data from gas sensor, the air quality value and the corresponding level will be displayed in the LCD display panel, and which is just like shown in the image. And the buzzer and LED will act as an alarm, which they will be on if the air quality level is considered at very poor level, just like shown in the image. And they if they remain in the on status for a long time, it's indicated that the indoor environment may not be suitable for staying too long, which reminds the users and the customers. And they will be off after uh, they will be off and collect a new data and just looping. And the below part, the image is the serial view, which shows the air quality value and the corresponding level, which is identical to what it shown in the LCD display panel. So for the hardware design, the components that we will add in the future is the temperature sensor, which is a TMP36 module, and we will add this in our design, which we want to track and show the data of the temperature in the indoor environment as well. And the Wi-Fi module is for the sending the data to the server and also to the website for further analysis, and also for the customers and users to view the data online in real time. And we would like to we may add the button to prompt the user input, as we want to have more interaction, and maybe we want to prompt the users to type some word to control the system on and off. So yeah, this is the part that we may add in the future, and this is my responsible part, and I would like to pass to my teammates Fong to explain more about our software design.
I'm Chen Feng, responsible for the software design of our project. Now I'm going to introduce you our software design and the progress. The software design of our project could be divided into two parts. One is the programming on the Arduino, and the other is an app for the customer to view the air quality information online. First, for the Arduino programming, we want to program the Arduino board so that it could coordinate, control, and communicate with the peripheral components. Thus, every component could function properly. How do the Arduino read the data from the sensor? How to display the result on the LCD screen? How to trigger the LED and the buzzer according to different situations? How to transmit the data to the local computer through a Wi-Fi module? All of the above functions could be accomplished by the programming. For the data collection, it is about how do we read the data from the sensor. The Arduino would get the data by the analog read function, which gives the analog voltage according to different voltage outputted by the sensor. Then we have to transform the voltage into meaningful information. For example, for the temperature sensor, we could get the temperature in Celsius by the following equation. We multiply the voltage by 5 divided by 1024 and then minus 0.5 divided by 0.01. However, it is not the case for the gas sensor. Since the gas sensor measures the concentration of different air particles but only gives one output voltage, it is hard to tell the exact concentration of each air particles, but it still gives us the relative index of the air quality. The higher voltage, the more polluted air. The system would keep reading the sensor and updating the data by loop. For the display on LCD screen, we want to show the measured data on it and keep it updated. We would use the library liquidcrystal.h which could works for all LCD displays that are compatible with the Hitachi HD447X0 driver, which could be recognized by its 16 pins interface. The library provides many functions such as begin, clear, set cursor, display, print, etc., which could help us to utilize the LCD screen. At the beginning, which means the setup of the Arduino, we must call the begin function in order to initialize the LCD, and the print function allows us to show the text on the screen while the clear function could make the screen clear. Again, we want to keep it updated, so we put all functions inside a loop. For the LED and the buzzer, it is used as an alarm. The Arduino will keep tracking the recorded value. If the value exceeds the safety level, then the Arduino will send a digital high voltage to trigger the LED and the buzzer to alert the employee. The alarm will be reset if the value returns normal, or it could be turned off by the management cast. And for the Wi-Fi module, the model is ESP8266, and we would include the library software serial.h because we want to establish a serial communication between the Arduino board and the Wi-Fi module. And we would control this Wi-Fi module by using AT command. At the beginning, we will set the baud rate of the Arduino and the serial communication channel to be 9600, and we will set this Wi-Fi module into mode 3, which include both access point and station mode. And we haven't finished the configuration of the Wi-Fi module, so it will be complete later. And for the apps for clients, It is for our customer to view the air qualities of different branches on their electronic devices. It will be more focused on the interface design to make it more reader-friendly, and it will send a notification to alert the user if any branches are having poor air quality. The app will receive the data from the cloud server. Again, we haven't do it yet, and it will be done in later. And then my teammate will tell you about our design on the database and the cloud server.